Hey folks, welcome back. In this video, we are going to talk about Python itertools module. Python itertools module is a built-in module and it provides a fast and memory efficient way of looping through variables. So we categorized in itertools module into three categories, that is infinite iterators, itertool functions, and combinatoric iterators. So in infinite iterators, we have three functions, that is count, cycle, and repeat. So let's start with count. So count takes two parameters, that is start and step. So start is the initial starting point of the counter, and the step is the incrementation part. So let's look at with simple example. So let me go to playground, and first we need to import the count from itertools module, that is from itertools import count. So once we have the count, and we need to create the object for count, so using the function count. So once that is counter equals to count of start equals to 1, and we didn't specify step, so by default the step value will be 1. So when we use this counter, and we if we want to check if whether it is infinitely generating the numbers or not, then we just need to use the for loop. For number in counter, print number. So it's a simple for loop that prints the numbers infinitely, because we are using the infinite count. So let me run python playground.py. So once we run it, we can see that in the terminal it's printing infinitely. So I just need to stop it. I just stopped it. So that's how we use the counter when we want to generate the numbers infinitely. And if you want to generate something like, if you want to increment it by 2 or 3, something like that, and then we can just simply use step equals to 2. And let me just check if number is greater than 10, then just break it. So let me run it python playground.py. So here we can see that it's generating 1357, and the difference between the two numbers is 2. One for the difference is 1 between 1 and 3 is 2, and 3 and 5 is 2. So that's because we used step equals to 2. If we use step equals to 1, and then it just simply increments by 1, 1, 2, 3, 4, 5, 6, something like that. So that's about count, and let's look at this cycle. So cycle function accepts an iterable and generates an infinite iterator. So let's look at the code here. Let me copy it to playground. So if we look at this code, so we imported the cycle from itertools module, and then we created the sequence using the cycle function, and cycle function accepts one argument or our parameter, that is 1, 2, 3. The list. So if we iterate through the sequence, and then it keep on iterating 1, 2, 3, and after that again the same sequence 1, 2, 3, and after that again the same sequence 1, 2, 3. So let's try that. I just want to remove this part, or yeah, let's try and check it. Python playground.py. So when we run it, like we can see that 1, 2, 3, and after that it generated 1, 2. So let's say if I want to increment this to, let's say count value is greater than 10, then break it. Okay. So now let's look at the code. So here we are just iterating through the iterator, and then we are printing the number. If the number is greater than 10, then we are breaking the loop. Let's run it python playground.py. So here we can see that the sequence is keep on repeating infinitely. That's because we are just using the break statement here. That's why it's not generating infinitely. But if we remove the break statement, it will infinitely generate. But before that, we can observe here 1, 2, 3, the sequence again. After that, we have 1, 2, 3, and after that, we have 1, 2, 3. So something like this, it will iterate the given sequence infinitely. So let's try removing the break statement and run it. Python playground.py, and we can see that it's keep on generating the sequence infinitely. So that is a cycle. And let's go back here, and let's talk about repeat. So repeat, let's say when we give a number 10, and if you want to repeat it for 10 times, and then we can go for a repeat function. So let me copy this code. So we have two cases here. One is we can give the number of times we want to iterate the given element, or if we just remove this 10, then it will generate the number, or the whatever the sequence that is given is infinitely. So I just imported the repeat from itertools model, and then I'm creating the object using the repeat function, and the element that I'm passing is 2. So let's say if I want to pass 1 2 3, and then I want it to iterate for 4 times, and then I can simply use the for loop to iterate, and then after that I'm printing the number. Actually it is not that number, so let's call it as element, and then use that variable. So now we have this. Let me clear this out and run python playground.py. So once we have it, so it just printed 4 times whatever the element that I'm passing here. Let's say if I want a number 2 for 4 times, and then I can simply update and run it. So this is how we get n number of times the given element. So if I just remove the 4, then it generates the whatever the given element infinitely. So here we can see that it's generating infinitely. So that's how we use the repeat function in itertools model. So let's talk about functions now. Let's talk about itertools functions. So we have 12 functions, and let's discuss one by one. So let's start with accumulate. So accumulate takes two parameters. One is iterable, and then the function. So it applies the function on elements of the iterable, and then creates the iterator. So let's try that. I'm just copying the code just to save the time. So just replace it, and if we look at the code, so we imported the accumulate function, and then we created the iterator using accumulate function. So for that we are passing the numbers 1 to 5, and then the lambda function that returns the sum of the two numbers that were given. So it just uses this and creates the uh, iterator, and then after that we are iterating the items in the iterator, and then printing the items. So let's save it, and let's fix the okay, fine. So let's run python playground.py. So when we run it, like, it accumulates the numbers by adding it. So let's run it. So if we look at the output, so it accumulated the numbers. So 1 plus 2, that is 3, and 3 is passed to the next function along with the next data, that is 3, and 3 plus 3 6, and after that, and 6 plus 4, that is 10, and 10 plus 5, that is 5. So that's how the accumulation um, function works. So let's look at the other function, that is chain. So let's say we have multiple iterable elements, and we want to iterate that in a single function, or sorry, single for loop, and then we can use the chain. So let me do that. Let's say we have iter 1 equals to 1 2 and 3, and iter 2 equals to, let's say, a b and c. So if we want to iterate and print the elements, and then we need to write two for loops to do that. Let's say for item in iter 1, and then print uh, item, and then let's copy the same for loop and use the iter 2 and print item. So if we run this code on playground.py, so we get 1 2 3 and abc. Let's say if you want to achieve it using only one for loop, and then we need to use um, itertools chain. So let's copy the import statement from there to here, and we have the chain function, and let's create the iterable equals to chain of iter 1 comma iter 2. So it just creates an iterable, and we can use the one for loop to print the all the elements. So let's clear this out and run python playground.py. So now we can see that we got the same output as before. just using the one for loop using itertools.chain. So that's how we use the chain. And let's look at the chain dot from iterable. So it works the same way, but the input will be a bit different. So let me copy the code just to save time. So if we see here, our data is something like we have a list. Inside we have one more list, and after that we have a set, and after that we have a string. So which means we have iterables inside a iterable. So if you want to unpack all these elements, and if we want to print something like 1 2 3 4 a b c, and then we can do that using chain dot from iterable. So if we run the code, we can able to see what we are talking about. So let's run it. Let me clear this out and run python playground.py. Right? So when we run it, we can see that we are accessing one element from the iterable of iterables at a time. So first time in first iteration we got one, and after that we have two, three, four, A, B, C. So this is how the chain nut from iterable function works. So let's look at the other function, that is compress. So let's look at the definition for this. So it makes an iterator that filters elements from the data, returning only those who have a corresponding element in selectors that evaluates to true. So let's copy this code to our playground and replace it. So yeah, so let's look at the code now. So we have the data that is A, B, C, D, E, F, and we have the selectors that is the values that we are going to evaluate it to. So here we have 1 0 1 0 1 1, and every value that maps to the data. So when we use compress, so it evaluates the truth value from the selectors, and then if it is true, and then it keeps the element. If it is false, and then it skips the element, and after that it creates an interval. So that is result. Let's run the code, python playground.py. So if we run it, like we can only see A, C, E, F. That's because one evaluates to true, and 0 evaluates to false. So let's say if we have here true and then false, something like this also, it will also work the same way. So let's run it again. Let me save it first and then run it. So we got the same output as before. That's because it evaluates the selector's value, and then if it is true, and then it keeps the element from the data. Otherwise, it just skips it. So that's how compress works. So let's look at drop while. So it makes an iterator that drops elements from the iterable as long as the predicate is true. So it takes the data and a predicate function, and it creates an iterable out of it. So let me copy this code to the playground, and let's discuss. So here we have the simple function that is predicate. The predicate, what it does is like it just checks whether the value is less than 5 or not, and we have the data here that is 14641, and when we pass the data and predicate to drop while function, so what it does, it checks the whether the predicate is true or false. If it is true, and then it just skips the element, otherwise it will return the data from there. So until this predicate function returns false. So let's run it. So open terminal and run python playground.py. So once we run it, we can see that we got 641. So that's because first it takes the 1, and 1 is less than 5, that is true. So that's why it skips this, and after that it takes 4, and it checks 4 is less than 5, that is true, and it skips it, and next time it takes 6, and it checks whether the condition is the predicate function is returning true or false. 6 is less than 5, that is false. So that the condition is returning, I mean the predicate is returning the false. So that's why it just returns the remaining elements from there. So that's why we got 641. Let's say if we have 3 here, and then it gets we get 4641 as output. So yeah, that's how the uh, drop while works. It just takes the predicate function, it evaluates the data by passing the elements to it. So if it returns true, and then it skips the that element. If it returns false, and then it just returns the all elements from there. That is drop while and filter false. So it also takes the predicate and iterable and makes an iterator that filters elements from the iterable, returning only those for which the predicate is false. So if the predicate is false, then only it will return the elements. So let me copy this code to playground and just remove the old code. So now we have the code. So we imported the filter false function from itertools, and we have a predicate that checks whether the given number is divisible by 2 or not. And we have the data 1, 2, 3, 4, 5, 6. And when we pass the data to filter false and the predicate, it takes the predicate and the data. So once we do that, like, it just checks the elements whether the predicate is true or false. So if it is false, and then it keeps the element. If it is true, and then it just skips the element. So by doing that, it creates the iterator, and we are using the for loop to iterate through the elements that were created in the created using filter false. So let's run it. Let me clear this out and run python playground.py. So we got only 135. That's because the other numbers, that is 2, 4, 6, those are divisible by 2. So the predicate returns true when the predicate is then when the predicate returns true, and then filter false just skips it. It only returns the values that the predicate evaluates to false. So that's how filter false works. And now we have group by. So let's say we have a data and we want to group the data using some key or some condition, and then we can use the group by. So group by takes iterable and the key to it, or the function. So here we have the data. Let me copy this to playground, and let's look at the code now. So in data we have addresses, only two addresses. We have same pin code, and the other one has a different pin code. So if we use the group by, and we are passing the data to it, and we are also passing the function to it. So the function's responsibility is to return the key uh, that will be used for the grouping. So in this case, we are using the pin as a key, and we are grouping the addresses. So these two 560076 pin code has two the first row and the second element, that is Satyajit and Pritham. So these two guys has the same pin code. So that's why we will be grouping them as a one. So let's run it. So here we can see that we got for this one 560076 key, we have the group, that is two, Satyajit and Preetam, and for other one, that is Mukul, we have only one. So like this, based on the key, we just group the elements. So we got key and iterator. So let's say if we just want to print the iterator, we just yeah, we just guess the group by object. Let's say if you want to convert that to a dict, and then we can do that using a dict function. And so now we can see that we have keys and the iterable grouper object. So that's how group by works. Let's look at islice. So islice takes iterable, and it slices the elements, or it selects the elements from the iterable. So let me copy this code to playground. Let's remove the old code, and now let's look at the code. So we imported the islice function from the itertools, and we created the iterator object and islice. So we are using the function and passing the hello Python. This is the data, and this is the start index, and this is the end index, and we are selecting the next element by increasing the index to 2. So as we are increasing, so 0th position we have H, and if we increase the index position to 2, and then we get L, and after that if we increase the position to 2, and then we get space, and after that something like that. So let's run this code. So if we look, oh, we should use Python playground.py, not just Python. So Python playground.py. So we got HLOP. So that's because if we add the um, indexes to it, let's go here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. So in first position, in 0th position, we have H, and in second position, we have L, and we have 4th position, we have O, and in 6, we have P. So we are only selecting the index from 0 to 8. So that's why we got only that. Let's say if I am just selecting till index 6, and then I get a different output. Let's run it. So now we got only HLO, that is 0, 2, and 4. So that's how it works, iSlice. So it just selects the elements based on the conditions that were given to the iSlice function. Let's talk about pairwise. So let's look at the definition. So it returns the successive overlapping pairs taken from the input variable. So let's say here in the code we have A, B, C, D. If you want to create a pairs, and then we have A, B, and B, C, and C, D, something like that. So let me copy and let's see how it works. Just remove the old code and paste it. So we just imported the pairwise function from the itertools, and then we created the iterator using pairwise function, and then we are iterating we are iterating through the iterator and printing the pairs. So let's run it, Python playground.py. So now we got AB, BC, and CD. So that's because they are adjacent to each other. So AB and BC and CD. So something like that. So that's how pairwise works. And let's look at star map. So when we talk about star map, let's say we have a function and we want to pass, let's say 10 arguments or 10 different arguments to it. So and then we just and in that kind of cases we just use the star map, and we pass the arguments, and it executes and it gives the result back. So let me copy this code to playground. So if we look at the code, we imported the star map. After that, we have a function that is a simple function that gives addition of two numbers, and we have arguments. So we want to pass 1 comma 1 and 2 and 3 and 4 to it. And let's say if we have 100 or 200 arguments we want to pass to it, we don't need to loop through it and pass the data to it. So we can use star map, and star map takes the function and arguments to it. So each element will be passed to add function in this case, and it returns the result, and that result is stored in the result iterator that is created from the star map. And after that we are just iterating through the result and we are printing it. So let's run, oh, before that we need to save it. Now let's run python playground.py. So if we run it, we got 3 and 7. So 1 plus 2 is 3 and 3 plus 4 is 7. So let's say if I want to pass one more argument to it, and then let's say 50 and 90. So now we get 140, that is 50 plus 90 is 140. So this is how we use the star map and pass the function and get the output. And we have one more function, that is take while. So it also takes a predicate and an iterable. So it makes an iterator that returns elements from the iterable as long as the predicate is true. So it only returns the elements when the predicate is returns the value as true. So let's look at, let me copy this to playground, and we have take while. So here we have a simple function that checks whether the given number is less than 6 or not. And we have the iterator that is created from the take while. We are passing the predicate that is less than 6, and we are passing the data. So in data we have 1, 2, 3 and 6, and then after we have 4 and 1. So it checks the element whether the element is less than 6. If the element is less than 6, and then it just keeps the element, and if not, it just skips it. So until and unless this predicate returns the false, then it won't stop. If the predicate is returns true, and then it just creates the iterator. So let's run it. Python playground.py. So we got 1, 2, 3. That's because after 6 the predicate returns false. Then it just skip the remaining part. So let's say if we have the 4 here and 6 here, and then we get 4 as well. So though we have a less number, that is 1 after 6, that won't be included in the iterator that was created from the take while. So this is how the take while function works. And we have t function. So it takes an iterator and it returns n independent iterators from a single iterable. So let's look at the code. I'm just copying the code to playground. So here we are importing the t function from itertools module, and we have the iterator or the items that we defined here, that is 1, 2, 3, 4, and we are creating the duplicates of that item for 2 times. So that is iterables, and we have the item in iterables of 0. Okay, let me just save this, and so now just print list. I'm just converting the iterable to list. Iterables. Okay, so now let's run it. So if we look at, so we got 2 iterables from the t. Let's say if I add number to 4, then we will get 4 iterables. So now we can see here the 4 iterables. So let's say if I want to iterate through each iterable, and then I want to print it, I can just do something like for iterable in iterables, then print list of iterable. So let's run it. Python playground.py. So if we look at it, we got 4 copies that were created from the original items. So t just repeats the data n times. Let's say if I give 10 here, so it just repeats the iterable 10 times. So that's how t works. Let's look at the one more function, that is zip longest. So zip longest makes an iterator that aggregates elements from the each of the iterables. So let's say in this case we have ABCD, and the grades is 1, 2. Let's copy the code to a playground, and let's discuss. So here we have imported the zip longest from the itertools module, and we have the data students A, B, C, D, and we have grades 1 and 2. Okay, so if we do zip longest, so A, B, C, D. So when we map the data A to 1 and B to 2, so the remaining part, that is C comma D, won't be there. Let's say in Python we already have a zip function, that is output equals to zip of students, okay, students and grades. Okay, so now if we print it, let me comment out this one for now, and print output. I'm just turning that to a list, Python playground.py. So here we can see that we got A to 1 as a pair, and B comma 2 as a one more pair. That's because we only have data for 2 elements. So this is the this grades has a length value 2. So that's why we got that. So if you want to keep C and D also, and then we can use the zip longest. Um, like this. I'm just uncommenting it. So now we are creating an iterator, and we have students, grades, and if the value is not there, and then we are just filling that with hyphen value. So if we print the same thing using iterator, or sorry, as it longest, and then we get this Python playground.py. So now we got A21 and B22 and C2 hyphen and D2 hyphen. So this is how zip longest works. So we covered all 12 functions from excuse me, itertools model. Let's discuss combinatoric iterators. So we have four functions in combinatoric iterators. Let's discuss one by one. So let's start with product. So product just returns the Cartesian product of the given input variables. So let's look at how we can use it. Let's look at a simple example here. So in the code, we just imported the product from itertools model. After that, we have the two variables, that is S1 and S2. And we are creating an iterator using product function, and we are passing the variables S1 comma S2. So when we pass it, like, it creates the Cartesian product. Here we have A, B, D, E. So it just maps A to D and A to E, and B to D and B to E. So we will get A, D, A, E, and B, D, B, E, something like that. So we will get as a base. So we are just iterating through the iterator, and we are printing the item. So it's a simple code. So let's run it, Python playground.py. So if we run it, we got AD as a tuple, and AE as a tuple, and BD as a tuple, and BE as a tuple. So that's how we create the Cartesian product using product function. So let's talk about the permutations. So let's say we want to create permutations from the iterable, and return R length subsequences of elements from the input variable. So R is a length of the subsequences that we want to generate. So let's look at the simple example for this as well. So let me go to playground and remove the existing code. So now we can see that we imported the permutations function, and we have the data that is 1, 2, 3, and we want to generate the permutations of length 2. And so when we pass the data and the length to permutations function, so it creates the iterator, and that is the result. And after that we are just iterating through the result and printing the generated permutations. So let's run it, Python playground.py. So once we run it, we get 1213 and 2123 and 3132. Let's say if I want to generate length of 3, and I just need to update the length to 3. So once we do that, we get 123 and 132, 213, 231, 312, and 321. So something like that. So if we want to generate something like this, the permutations, and then we can just simply use the permutations function. So let's look at the other function, that is combinations. So it returns the R length subsequences of elements from the input iterable. So it just returns the combinations of the given input with length R. So it's also very simple. So let's go to playground and remove the existing code and paste. So now we have 1, 2, 3, and we want to generate the combinations of length 2, and then we can simply give 2 here, r equals to 2. So for combinations, we just need to give the data first, and after that we need to give the length. So once we do that, it creates the iterator, and we can simply iterate through the iterator and print the items inside it. So let's run Python playground.py. So if we run it, we got 1, 2, and 1, 3, and 2, 3. So these are the three different combinations that we get. That's how we use the combinations function. And let's say if we want to have combinations with replacement, and then we can use the combinations with replacement function. So it takes the iterable and our length to it. So it works similar. So if you look at the definition, so it returns R length subsequences of elements from the input variable, allowing individual elements to be repeated more than once. So that's the difference between combinations and combination with replacement. So let's look at the simple code. So yeah. So if here we have the numbers 1, 2, 3, and we are generating the combinations with replacement. So if we run it, we get the more number of combinations now. Python playground.py. So now we get 1 1. So we have a repetition of one element, and we have 1 2 1 3 2 2 2 3 and 3 3. So if we just use the combination, so we get only a fewer number of data to it. Combinations. So we will get only 3 because the element itself is not repeating in the combinations. So that's the difference between combinations with replacement and the combinations. So these are the functions that we can see in combinatoric iterators. If you find this video is useful, then please like the video and subscribe to my channel. Thank you.